This is a driverless car navigating traffic all on its own. And this is a delivery drone dropping food straight from the sky in minutes. China is not testing the future anymore, it is already building it. And in this video, we are going to see how far it really goes. Not long ago, speed and delivery had a clear limit. No matter how efficient things got, you still had to deal with traffic, distance, and human movement. There was always a delay you could not escape. China looked at that limit and decided it did not have to exist at all. Instead of improving roads or hiring more riders, they went in a completely different direction. They moved delivery into the air. Today, companies like Meituan are running large-scale drone networks that can deliver food in around 15 minutes with striking accuracy. This is not a rare experiment. It has already been done hundreds of thousands of times. The system is designed to remove friction. Drones follow fixed aerial paths and drop orders into secure collection points, cutting out delays and confusion completely. And it does not stop in busy cities. With JD.com, larger drones now carry heavy packages across rural areas, reaching places that once struggled with basic delivery. Now let's talk about something that genuinely feels like the future arriving all at once. This year alone, millions of new cars in China are coming with built-in intelligence that allows them to drive on their own. We are not talking about a small upgrade or a fancy add-on. We are talking about a major shift where a large portion of new vehicles can handle driving tasks without constant human control. That means, for many people, the idea of always holding the steering wheel is slowly becoming optional. But then there are cars that take things even further. One standout example is the GAC Ion Hyper GT, often discussed as part of a new generation of vehicles built around real artificial intelligence. This is not just about following lanes or maintaining speed. This is about interaction. The car includes an AI system known as SIMO, designed to communicate naturally. You can call your car from a distance, and it can actually drive itself to your location. It feels less like using a machine and more like interacting with something that understands you. What makes this possible is the level of technology packed inside. These vehicles are equipped with powerful AI chips, high-definition cameras, radar systems, and multiple layers of sensors working together at all times. They constantly scan the environment, detect movement, read traffic signals, and make decisions in real time. Parking, lane changes, obstacle avoidance, and even complex turns in busy traffic are handled with a level of precision that used to sound unrealistic. And then you have companies like BYD pushing boundaries in ways that almost feel playful. Take the Yangwang U8, for example. This is an SUV that can spin in place, performing a full rotation without moving forward. It can also move sideways into tight parking spaces, something that would normally require multiple adjustments. Even more surprising, it can handle deep water. In extreme conditions, it can float and move slowly, giving drivers a way to escape flooded areas. Another impressive model is the IM Motors L6, which uses advanced steering to slide neatly into parking spots with minimal space. It reduces the stress of parking in crowded areas and makes tight spaces feel manageable. In a similar way, the BYD Denza Z9 GT can perform controlled slides into parking positions, turning what used to be a difficult task into something smooth and almost effortless. Then things move into the world of pure performance. The Yangwang U9 is built for speed, reaching incredible acceleration levels that rival the fastest cars ever made. But speed is not even the most surprising part. This car is designed with a suspension system that allows it to move in ways most people have never seen before. It can lift itself slightly off the ground, adjust each wheel independently, and even create movements that look like dancing. This is powered by an advanced system that reacts almost instantly, adjusting the car's position in milliseconds. It is not just for show. It improves stability, handling, and control at high speeds. Still, the visual effect is unforgettable. Watching a high-performance car move rhythmically like that changes how people think about what a vehicle can do. China did not stop with smart cars and fast charging. They pushed forward into transportation in a way that feels almost unreal. The country has developed magnetic levitation trains, often called maglev, that do not even touch the tracks. Instead of rolling on wheels, they float using powerful magnetic forces, which removes friction and allows them to reach extreme speeds. One of these trains has already reached about 404 miles per hour in just a few seconds during testing. That is faster than many airplanes during takeoff. In further experiments, Chinese maglev systems have pushed beyond 600 miles per hour, entering a speed range that competes directly with aircraft. Projects linked to China Railway Rolling Stock Corporation are leading this development, aiming to make ultra-fast ground travel a reality. With speeds like this, long-distance travel changes completely. A journey between Beijing and Shanghai, which usually takes over 5 hours by conventional high-speed rail, could be reduced to around 2.5 hours. That kind of efficiency reshapes how people think about distance. But China is not only building advanced machines, it is also preparing future generations to control them. In cities like Beijing, children as young as 6 are now introduced to artificial intelligence in school. These lessons are not optional extras. They are part of a growing effort to make AI education normal from an early stage. At the same time, automation is expanding into construction. Fleets of autonomous trucks are now being used to build roads, operating continuously without human drivers, even in extreme weather conditions. And the scale keeps expanding. In China, road construction is now being handled by coordinated fleets of machines that operate almost like a single system. About 10 autonomous road rollers and 2 large intelligent pavers can now build stretches of highway using GPS mapping and real-time data instead of constant human control. They adjust pressure, alignment, and speed automatically, laying asphalt with precision that stays consistent across long distances. In a sense, the infrastructure is being built by the same type of machines that will eventually drive on it, creating a full loop of automation from construction to transportation. This push continues into freight transport as well. China is working toward deploying around 5,000 self-driving haul trucks across mining zones, ports, and industrial corridors. These trucks are designed for heavy-duty work over predictable routes, using sensors, radar, and AI systems to move materials with minimal human input. The speed of testing and rollout suggests the target could be reached sooner than expected. Airports show an even more visible change in everyday life. Across more than 60 airports, facial recognition has replaced much of the traditional check-in and security process. Instead of repeatedly showing documents, passengers move through biometric checkpoints that verify identity instantly. At major hubs like Shanghai Hongqiao Airport, travelers can complete check-in, baggage drop, security, and boarding in a highly automated flow with very little direct human interaction. Beijing Daxing Airport pushes this further with hundreds of biometric scanners, automated gates, and self-service systems working together to process large passenger volumes efficiently. Outside airports, China operates one of the largest surveillance networks in the world, with hundreds of millions of cameras linked into an AI system often called Skynet. It can recognize faces, track movement patterns, and flag unusual behavior in real time. In some cases, police use AI-equipped helmets that scan crowds and identify suspects instantly, showing how deeply automation and artificial intelligence have entered public life. China is also changing how people pay for things in everyday life. While most countries still rely on cash, cards, or mobile phones, China is already testing something more advanced. In some places, people can now pay using only their palms. The system works by scanning the unique vein patterns in the hand. Instead of tapping a phone or inserting a card, a person simply places their palm over a scanner and the payment is completed instantly. It may sound unusual, but it is already being used by millions of people. The technology is active in over 1,000 stores and is designed to be extremely accurate, with very low error rates. Because vein patterns are unique and hidden under the skin, it is also considered more secure than fingerprints. The use of palm payment is spreading beyond shopping centers. Students use it in universities to buy food, and travelers use it in transport systems like train stations. This shows a clear direction toward a future where physical wallets, cards, and even phones may no longer be necessary for daily payments. At the same time, China is making rapid progress in robotics. One example is the humanoid robot Unitree G1. It is about the size of a child but built with advanced motors and joints that allow it to move with surprising flexibility. It can walk, run, jump, sit, stand, wave, and even perform coordinated movements like dance or martial arts-inspired routines. Beyond movement, it can also assist with simple tasks like carrying objects or opening containers. It is designed to be programmable, meaning it can switch between different roles depending on what is needed. What makes it even more striking is its price. Compared to older humanoid robots that cost hundreds of thousands of dollars, the G1 is far more affordable, showing how quickly robotics is becoming more accessible and closer to everyday use. And it does not stop there. China has also developed advanced robot dogs known as the Go-To series, designed for real-world work rather than just entertainment. These machines may look like playful pets, but they are built for serious tasks. Weighing around 15 kilograms, they can move at speeds of up to 2.5 meters per second and stay stable even on rough terrain. Their movement abilities are impressive, allowing them to climb obstacles, recover balance quickly, and even perform complex motions like flips, rolls, and agile turns. What makes them even more advanced is their interaction system. They can respond to voice commands using AI-powered language models, which allows them to follow instructions in a more natural way. They can shake hands, perform basic gestures, dance routines, and even assist in simple observation tasks like taking photos or recording surroundings. Their perception system provides a wide field of view with nearly full directional awareness, allowing them to detect objects very close to them and avoid collisions in real time. Some versions can even follow a person smoothly while navigating around obstacles automatically. There is also a wheeled version designed for efficiency on flat terrain, capable of carrying small loads while moving quickly. These robot dogs have already appeared in public demonstrations, including major sporting events where they helped transport equipment on the field, showing that they are already being tested in real environments rather than just laboratories. Reports also suggest early use cases in security and patrol roles, where mobility and stability are important. Alongside robotic animals, China is also advancing humanoid androids through companies like EX Robots. These machines are designed to look almost exactly like humans, with realistic facial features, skin textures, and natural blinking movements. Each unit is built with a high number of motion points, allowing extremely detailed expressions and body language. Because of the complexity, each robot takes weeks to manufacture and costs hundreds of thousands of dollars. The company has already produced large numbers of these humanoid robots and is scaling up production. Some are placed in museums and public spaces where they interact with visitors 0:8 to 0:18, including recreations of historical figures designed to speak and share information. This raises new questions about how far human-like robotics can go, especially as the gap between machine interaction and real human behavior continues to shrink. China is moving fast, and whether you see it as exciting or overwhelming, one thing is clear: the future is already unfolding in real time. From AI cars to flying deliveries and robot-built roads, the pace of change is only getting faster. If you enjoyed this video, make sure to like and subscribe for more breakdowns like this, and tell me in the comments which of these inventions surprised you the most.